Good evening one and all. Welcome to Design of Machine Elements Learning Series, Series 6, Design Considerations for Forgings, Machined Components and Welded Assemblies. The objective of the presentation is to understand the design considerations for forgings, machined components and welded assemblies. Forgings. The common materials which are used for forged components are steel and non-ferrous alloys. Engine mounts, brackets, piston pin, connecting rod, etc. are few examples of forged components. It is found that components which are subjected to motion are usually light in weight. Example, connecting rod which is forged. Components that are subjected to excessive stresses like aircraft structures are also forged. And components where there is a need for pressure tightness like valve bodies are also forged. Here are few design considerations a designer should consider for forging drawings. First, fiber lines. In forged components, fiber lines are arranged in a sequential manner to withstand stresses caused due to external forces. Hence, a design engineer should take advantage of this property while designing forged components. Second, selection of profile. The profile selection is important in forged component design. The design should be made in such a way that the fiber lines are parallel if the forged component is subjected to tensile force and perpendicular if the forged component is subjected to shear force. Adequate draft angle. The designer should provide adequate draft angle in forging drawings. Draft is an angle for ease removal of component from die. The draft angles are provided internally and externally respectively. It should be noted that draft angles on the outer surface are small and on the inner surface are large. It is advised to avoid deep machining cuts. The designer should avoid deep machining cuts because in forged component, the cut breaks the fiber lines and makes the component weak. Provision of adequate fillets. Smaller and larger fillets should be avoided in forged components because smaller fillets on the inner surface causes folds and on the outer surface causes cracks, as well as presence of large fillets causes the fiber lines to break if the component is subjected to machining. It is advised to avoid sharp corners because it causes a difficulty to fill the material, results in excessive forging forces and poor die life. Parting line and forging plane. A parting line is a line in which two halves of the forging die meet in which flash is formed. If the parting line is broken, it results in unbalanced forging forces in both halves. Thin sections and rips should be avoided in forged components. Now, let us study the design considerations which are required for making machining drawings. Exactly where do we use machining? Components requiring high accuracy and precision, complete flatness, roundness, parallelism, parts having relative motion with each other and interchangeable assembly are few applications of machining components. Here are few design considerations to be considered by the designer while making a machining component design. First and foremost is avoid machining. Machining is an expensive manufacturing process as compared to casting and forging. So it is advised that it should be avoided as far as possible. Specification of liberal tolerances. While designing the components, the designer should provide liberal tolerance in drawings, both geometric and dimensional, because closed tolerances results in high machining costs. It is advised to avoid sharp corners because it results in stress concentration. It is also advisable to use raw materials available in standard size and use of stock dimensions to avoid machining operations. Components with thin walls and webs should not be used as they cannot withstand stresses caused by forces of different machining operations. Shoulders and undercuts should be avoided as it increases the cost and requires special tools. It is found that it is difficult to machine hard materials, hence they should also be avoided. Now let us understand what are the design considerations for welded assemblies. As a designer, you should understand that welded joints are permanent joints, which means the failure of a welded joint will result in the complete failure of the assembly. What are the design considerations for welded assemblies? First, select a material with high weldability. A material having maximum carbon content of 0.22% should be selected. High carbon steel cannot be welded or should not be used because it causes the weld to harden at the joint and the weld is susceptible to cracks. Use of minimum number of welds. It is advised that in order to prevent distortion, the designer should provide minimum number of welds as it reduces cost. Use of standard size plates, bars and rolled sections are preferred. Avoid use of straps, laps and external stiffeners. The designer can increase the stiffness of plates to be welded by providing or increasing the bends, rips and corrugation using pressing operations. Stiffeners are needed to provide rigidity, but it is preferred not to use external stiffeners as it increases cost. It is important for the designer to provide or select proper location for the weld, so that the position of the weld should be selected in such a way that stresses and deflections are not critical at that point, as well as the position of the weld should be such that the welder and the welding machine has unobstructed access. It is the responsibility of the designer to specify and prescribe correct sequence of welding. The following presentation is made by studying the following references: a textbook on design of machine elements by V.B. Bhandari, Tata McGraw-Hill Publications, design of machine elements by K. Ganesh Babu and K. Sridhar, and machine design by R.K. Jain Khanna Publications. Thank you very much and wish you a happy learning.